Hi, so we're going to do the last exercise in here regarding the disk method, okay, at least for now regarding solids of revolution. So this thing here, for the first time, it's not going to be revolving around the y-axis, it's going to be revolving around the x equals 2 axis, okay, which is this one here, which is down here, see? Okay, so the p of x is the distance from the bar, because we want to know as soon as we make a solid revolution regarding this thing here, okay, what's going to be the volume. You see that this is going to be a hole, this is going to be empty, okay, and this is going to be empty too. The only thing that's going to be part of the solid is this stuff in here. Okay, so let's think about this bar, okay. When the bar, this is x equals 2, so when x equals 2, the p of x is actually going to be 0 around the axis of revolution, because the axis is not here, the axis is in here. So when x equals 2, the distance is just going to be 0, okay? Of course, the x is never going to be 2, because we're not going all the way here, right? We're going from x equals 0 all the way to x equals 1, which is here. But anyway, when x equals, well, in this case it's a coincidence, guys. See, when x equals 1, the distance is going to be 1. But when x equals 0, the distance is not going to be 0. The distance is going to be 2, which is 1 plus 1, right? So that's why p of x is 2 minus x. Now, think about this for a second. You have something here which is x cubed plus x, right? X cubed plus x is going to do something. It's going to do something in this same format, but instead of being here, it's going to be down here. Okay. Now, of course, because you see, for example, let's just plug in 0. When it's 0 plus 0, when x is 0, okay, where's the point? The point's right here. And what is that point? 0 and 1. So you need this plus 1 in here. Transform it into 1. Okay, what about when x is 1? X is 1 and the thing is going to be 3 because it's going to be 1 cubed, which is 1, plus 1 plus 1. That's 3, right? But here's the thing. Is this distance, for example, from here all the way to here, should all this distance be accounted, all this stuff in here? No, it should be this distance minus 1. Because the whole graph is just starting, the whole area that we're interested in, it's starting right here in y equals 1. So you have this this function, okay, which makes this blue stuff, but we don't want to, we want to discount, we want to subtract this distance right here. Because, for example, you see, what is going to be the value of f of x in here? It's going to be this y. Okay, and this y is going to go from here all the way down there, but you see the length of the bar doesn't go all the way down there. It's this minus 1, and then you're going to have the length of the bar here. Okay, so all we got to do is to use the shell method. It's going to be 2 pi times the integral of p of x, okay, meaning the distance from the bar. For example, this bar right here, I gotta keep changing the colors. This bar right here is gonna be this distance. This bar right here is gonna be this distance. This bar was this distance, okay? So, which is gonna be what? 2 minus x times this function, which is x cubed plus x plus 1 minus 1, so it's just x cubed plus x. So x cubed plus x dx. And we're going to be integrating from x equal to 0 all the way to x equals 1. Okay, so I'm going to do this thing here first. You're going to have, the only way you're going to, so I'm going to do this in the decreasing order of the power, okay, of x. So it's going to be minus x to the 4th. Yeah, maybe I should do this, maybe I shouldn't. Whatever. The only way that I can have an x cubed in here is like plus 2x cubed. I'm multiplying these things, okay? For me to have an x squared, the only way is by minus x squared. For me to have an x, it's going to be plus 2x. Okay, so there you go. So it's the integral of this, and I'm already going to do the integral of this, okay? This is going to be, I'm going to do it down here, 2 pi times integrating from 0 to 1, what? Minus x to the 5th divided by 5. Then you're going to have 2x divided by 2x to the 4th divided by 4. So it's going to be x to the 4th divided by 2 minus x cubed divided by 3 plus x squared. Okay, because it's 2x squared divided by 2x squared. Okay. Now taking the minimum common denominator. And you can see that you have x's, you have x in all the numerators here. So if you apply the zeros, you're gonna zero out the equation. So you don't have to worry about that. So, well, I'm not gonna apply actually the minimum common denominator right now. It's gonna be minus 1/5 plus 1/2 minus 1/3, right? Yeah, plus 1. So we'll do 2 pi. Now I'm going to do it. And guys, I think this thing is going to be 10, 12, no, 15. No. I think it'll have to be 20. It'll have to be 30. I'm going to do 30. So minus 6 plus 15 minus 10 plus 30. So there's going to be 20 plus 15, 35 minus 6, 29. So it's going to be 29 pi divided by 15. I'm simplifying this with this one. Okay. Let me see here. That's it. This is going to be a quick video because the next topic, then on the next video, I'm going to change the topic. I'm going to talk about the length of surfaces. Because if you have something, okay, just want to give you an intro on what we're going to be looking at. If you have something like this, okay, so here's the y-axis, this is the x-axis. Let's just say they have 1, 2, 3, 4, 5. Okay. Let's just say that I have a bar like this. What's the length? It's 3, right? Yeah. 1, 2, 3, 4, 5. So it's 5 minus 2. It's pretty simple. It's 5 here minus the 2 here. It's 3. But let's just say that instead of having this, let me erase here. Let's just say that I have something like this, a function, which does this, for example. Yeah. Now, let's just say that it goes all the way to 3 there. Okay. And you want to do here. Okay. So you want this length. What I'm trying to say is you get this, this end, and you just hold it. Pretend that you can hold this and you, with the left hand, and you hold this end with the right hand, and you stretch it out. So you bring all this stuff all the way over here, and you make it become a, oh man, again, you want to make it become like something stretched, you know, a straight line. So what's going to be the length of this straight line? That's what we're going to see in the next video.